This is problem 210 شايفين يا شباب؟
واضح دكتور.
Okay. فهنا it says problem 211, sorry, not 10. A block of 250 millimeter length and 45 by 40 millimeter cross section. So if you want to draw this, this is the problem that we have. So this block is 250 millimeter length. So this length is 250 millimeter. This size, assume this one is 40 and the other one millimeter. The other one is 45 millimeter. Okay, is to support centric compressive load. Centric means a load at the center, like this, in the center, not eccentric. Later on we will see a load somewhere here. So this load is applied there. Compressive, it is in this direction. If it is tension, it would be the other way around, or up. Now it is a compressive. Compression load, P. This load is P. Okay. The material to be used is bronze. Okay, this is well-known material for a lot of applications. Okay, for which E is 95 gigapascal. Can someone remind me what was the E of steel? It was
200.
from 190 to 210 megapascal. Okay. Determine the largest load. So he's asking for P maximum. Okay. Which can be applied, knowing that the normal stress must not exceed. Again, even here the allowable stress is 124 megapascal. Okay, and the decrease in length of the block should be at most 0.12% of the original length of the length. Original length. Now we have two design criteria. Okay, after we draw this, now let's quit stop share and go back to the problem. Okay, Shabab, clear? Okay, now this is the problem. This is problem 2.11. The length is 250. This is the cross sections. The maximum, actually this is strain, which is 0.12. If we write it in our engineering terms, or let's say it would be 0.00, because this percentage means another 20. Now, what is needed? What is the maximum P? Based on strength, cannot exceed this load, this strength, this is stress, and based on deflection or deformation, that it cannot exceed this. So we have two value of P. So let's start based, let's say based on
دكتور معلش الترين مو 0.12%، يعني هضرب ال 0.0012 في 250 صح؟
Later on, if you want to, okay, if you want to transfer this into deformation, yes. but he's not giving this as a deformation. He's not saying delta is 1 millimeter. He's giving this as percentage. So either one.
يعني ما يحتاج يفرق.
No need. We will see how do you solve this. Now, based on a strength, can someone tell me what would be the stress, the maximum stress? It would be force over area. Okay. What is the force يا شباب هنا؟ البي مجهولة، ما هي معطى. الاريا, what is the area؟
0.04 في 0.045.
Okay, and I want to write 0.04 في 0.045. إذا زميلنا ما هو عارف فين الاريا في 0.045. Okay. طيب this should be equal to ايش يا شباب؟ the allowable strength. Okay. Thus P maximum
223.2 في 10 أس 3 نيوتن يا دكتور.
إذا 223.2
في 10 أس 3.
إذا كيلو نيوتن. إذا now based on strain, which is deformation. Okay. If you go back to Hooke's law, we studied in this course, it says, or it was written or given to us as stress is equal to strain, which is given up, times the modulus of elasticity. Okay? Or in other words, strain is equal to the modulus of strength, stress, over the modulus of elasticity. Now, if we apply here, this was given to us as 0.0012 is equal to sigma over 95 times 10 to the power 9, which is E. Thus, we have another sigma here, which is 114 megapascal. Okay. Now again, based on this value, we can find the maximum force based on strain. So again, we will say sigma is equal P over A. Again, here is P. Area, what is the area now? Okay, 0.04 times
0.045.
45. And this is equal to
1.14
times 10 to the power 6. Type. Can someone solve for the P here? Okay. I think we should not call this P maximum from the beginning. Let's say this is P strength, based on strength, okay, strength, and this one P based on deformation. So P based on deformation is, how much is this?
205
Going to come to
كيلو نيوتن.
Okay. طيب. Thus, maximum allowable load كم بيساوي؟ نسأل. كم يا 205. Thus, P maximum is 205.2 kilo Newton.